All right, so y'all are looking pretty good. You start by looking at the first terms. X times what would give you x cubed? And that's x squared, and you line them up above the other x squareds. That's like just the mental math way of doing it. If you need a more methodical way, what I taught you in the notes yesterday was to actually divide those two things, because it is a division problem, and then that would give you x squared, and that's how you could get that right every time. And then you multiply that by the divisor, both parts of them, and that gives you x cubed plus 2x squared. And you're subtracting both of those off, right? You're subtracting off the entire thing. You can also think about that as just you're changing the signs of both of the things. So it'd be like that, a negative x cubed and a negative 2x squared. So these drop out. You combine those like terms, giving you x squared. You bring down the next one, and the process starts all over again, right? X times x gives you that x squared. So I'm going to do this faster now. Giving you x squared plus 2x. You're subtracting both of those off. So that gives you negative 6x. When I was walking around, most of the mistakes I saw were right here for not changing that 2x sign. Then you bring down that last number, negative 12. X times negative 6 gives you that. Multiply by your divisor. Math, 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 math. 0, okay? Your final answer is whatever's above the division house. If you want to write your remainder as a fraction, even though it's 0, that's okay. I won't require you to do it when it's 0, because that's really just nothing. So either of these is fine. Questions? I think y'all are pretty good on that. See, it's really not a hard process. It's just the same thing over and over. So synthetic division simulates long division, but it's only good when the divisors are linear. So please highlight this, mark it, underline it, put little hearts around it, whatever you need to do. If you love math, otherwise just put stars or arrows. This is a straight shortcut method, okay? And it works only when your divisors are linear. Like the divisor in the warm-up was x plus 2. The biggest exponent was 1. That's a linear, okay? It won't work if you're dividing by something squared or cubed. But the tricky thing is you could technically do it. You just won't get the right answer. So you have to be on the lookout before you apply this method, like on a quiz or test, that the divisor is linear. Otherwise, you won't be understanding that you're getting the answer wrong. And the way we set this up is we use the 0 or root of the divisor, which I'll explain, and we use the coefficients of the dividend. What I mean by 0 or root of the divisor in the warm-up was x plus 2. When I tell you what's the 0 or root of that expression, what do you feel like you would say? Like what makes it 0? What number? Negative 2, right? Technically what's going on is if you set it equal to 0, what number would make that true? And it's negative 2. So we're going to use this number to set up our shortcut method. And you might be thinking, well, Ms. F, why don't you just tell us insider's lie? Well, it's kind of not always that. If your divisor was something like this, you'd have to find the 0. It wouldn't be like a negative 5, like insider's lie. It would be a fraction, because you would subtract 5 from both sides and divide by 3. And that's what a 0 or root means. Now, everything we're doing today, I don't remember about your homework, but all the stuff we're doing today, it's an integer, so that'll be okay. But even when we get into problems with rational numbers, it's not ever that bad. We survive. You'll survive. No one's dying on my watch. Where have you seen this problem before? The warm-up, right? So we're going to do synthetic division, and guess what? It's going to give us the exact same answer, right? So at least we know what we're working towards. Now I'm going to go through the method one time, nice and slow, with lots of extra notes for you to take in the margin so you know how the process works. And then I'll show you how you can it's just going to go fast after that. But one time slowly. Okay. So the very first step is to do your setup. And here's how that looks. And you probably, I think you have done synthetic division in every previous math class. I'm not sure about regular algebra 2. But here's how it begins. You have a little box, and this is where the 0 goes for your divisor. And what did we say the 0 for this divisor is? -2. So this is the 0 or root of the divisor. And then on that last screen, when it said we use the coefficients, here's how that looks. What's the coefficient of the first term? I don't see a number. It's 1, right? The coefficients are whatever the number is in front of the variables. Okay, so those coefficients. And then we are about to put a whole row of numbers under that row. So skip enough room to allow for your handwriting and put a bar under here. Because we're going to do a bunch of little addition problems, and so we want that bar there. We're going to be adding. So this is the setup for the problem. And then here's how we begin. So I'm going to explain the steps on the left. You use whatever shorthand you need on your notes so that you still understand what's going on, okay? The first thing we're going to do is drop down, let's see, the first term, or the first coefficient. I like writing double F's in cursive. Like if I wasn't teaching right now, I would just do double F's. And then you will multiply the root, or 0, whatever you want to call it, by that term, or by that number that you just dropped down. And write the answer in the next column. So we're going to multiply the root by that number we dropped down, and we're going to write it in the next column, okay? So that looks like this. The -2 times this 1, and that goes right here. So -2 times 1 is -2. And then add those things. Add the 3 and the -2. So write the answer in the next column and add. And then here's where the process repeats. So repeat. So now that -2 gets multiplied by this one, and that number goes here. Add the -4 and the -2, -6. Repeat one more time. -2 times -6 is 12. And then you add and you get 0. What do you think is special about that 0, that number, that space right there? It's the remainder. Whatever number, bless you, whatever number you get right here is the remainder. And what about these other numbers? What's their significance? The 1 and the 1 and the negative 6. What, Kat? It's the number in front of the x squareds and the x, right? It's the coefficients of your answer. Because if you look back to the answer from your warm-up, it's what? It's 1 x squared plus 1 x minus 6. And then we had the remainder of 0. What is the relationship between this degree of x squared? How is that compared to the degree we started with? Minus 1 degree. Okay, so every time you do this problem, the very last step is to add your x's back in. So this is the last thing I'm going to write over here. So you have to add x's back in. Um, 1 degree less than the original problem. Or the original degree, whatever you want to write. And what I'm going to do here in a second is erase all that and just have you put your pencils down and look at me, just watch how fast it goes. But not until you're done copying or whatever you need to copy. Does anybody need this up anymore? Okay, I'm about to erase it. Yes, go ahead. Okay, so put your pencils down and just watch me do this without all the arrows and all the explanations, without all the bells and whistles, okay? This is how fast it will go. That's great, right? Way faster than long division, but you can only do this with what kind of problems? Linear divisors, right? You could technically, like if you could be doing it wrong on accident and not know it. Like if this was an x squared and you still did the negative 2, you'd still come out with the things, but the answer would be wrong. So you have to be on the lookout for if the divisor is linear or not. So just keep that in the back of your head. Take a moment and do this problem, please. You should get a remainder of 0. So if you did, you probably are. The x squared. What was I supposed to start with? X to the 1, right? Because the original problem was x squared. So when I put the x's back in, I have to drop 1 degree. All right, raise your hand if you got that right. Raise your hand and pat yourselves on the back. Good job, selves. For the next 2 problems, what's happening is that they're missing some terms. Yesterday for long division, when we were missing terms, I told you to use a 0 as a placeholder, but I said it's not 100% necessary. It's just good practice. However, for synthetic division, it is 100% necessary, or you'll get a completely different answer. So in the first problem here, which term is missing? The x squared term. So you're going to use a 0 in its place. This is the term that's missing. And just as a moment of critical thinking, how come in synthetic division there will never be a missing term in the divisor? Why wouldn't there? Yeah, it's already linear. If you had a missing term, you would be down to something else entirely. So take a minute and try this problem, please. I'm going to do it up here. I don't want you to look until you're done and you're ready to look. Don't look. Don't look at my work. No copying. And don't look, because then you can't unsee what you've seen, and then you might think you understand when you don't. And besides, I made a mistake on purpose, so. I did on purpose. It's called error analysis, and sometimes I did it on purpose. Every once in a while I do it on accident, and then pretend like I did it on purpose, but not this time. Yeah. So Matthew, what was my mistake? I put the 63 on the bottom. And here's why I did that. Sometimes students, they get to that last column and they feel like it should work differently than the rest of it because you're at the end. But it doesn't. It works just like all the other columns. So the 63 should go here, and then you add. Which of the numbers there is the remainder? 70. And I need to add my x's back in. What degree do I start with? 2. Very good. So the answer is 2x squared plus 6x plus 21 plus 70 over x minus 3. Okay. And then try the last problem. The last problem is missing lots of things. So if you went rogue somewhere, this is the most common 0 to miss. This one right here. Between the x squared and the negative 9. Who missed that 0? Yeah, that's the most common mistake. So let's set it up with that 0. What number goes in my little box? Okay. And then the other place that's weird is when you start getting the zeros everywhere. People feel like that. Well, here's what happens, bless you. Once you get this 0 here, people feel like the rest has to be zeros. But just keep doing the process. The numbers come back. Because yes, negative 3 times 0 is 0 here, but when you add, you have 1. And then negative 3, 9, and 0. When you add your x's back in, what degree do you need? Minus 1 from the original. So what will we do? 5. The degree is 5, right? For the answers. So we have 2x to the 5th minus 6x to the 4th. This is x cubed. I don't need to write that because it's 0, right? This one's x squared. I don't need to keep that one. This one is 1x and then minus 3. So check your degrees with mine, because when I was coming around just like spotting your answers, I may not have checked that your degrees were right. I might just have been checking your coefficients. And so that's it.